On Earth, living creatures have evolved under daily changes in light, the single most important component for life. Therefore, it is not surprising that genes encoding internal molecular clocks capable of anticipating these daily changes were selected over time, as they timed and optimized body physiology to reoccurring daily events. Internal molecular clocks emerged in cyanobacteria more than 2.5 billion years ago, enabling them to optimize photosynthesis throughout the day. Fast forward to today, internal molecular clocks have been described in many different organisms, including humans. The advantage of having an internal molecular clock is that it prepares the body physiology in anticipation to what will happen in the real world, thus enhancing fitness and performance. Imagine, for instance, that around noon, different organs in your body work together in anticipation to the meal you are about to have. For instance, salivary glands start to produce saliva and your stomach starts to produce acid. This anticipation optimizes food digestion and nutrient utilization. You probably have experienced that having lunch outside of this time window does not make you feel very good. Daily synchronization between different organ systems of the whole organism and the daily events in the external environment is critical to physiological health and psychological well-being. The breakdown of this 24-hour temporal order can lead to various diseases at many levels. This internal clock mechanism is the largest known regulatory network in normal physiology, and as many as 20% of our genes are expressed with a daily rhythm. The 2017 Nobel Prize in Medicine or Physiology has been awarded to 3 scientists for their pioneering contributions in elucidating the genetic mechanisms underlying the internal molecular clocks. The basic molecular principle underlying this internal molecular clock is represented in this image by the cogwheels. Each cogwheel illustrates different genes that participate in this mechanism. This is a very simplified diagram of the internal molecular clock, and I will not go into detail in this video. However, notice that these genes compose a feedback loop where the activated genes, purrs and cries, repress their own activators, clock and BMAL1. As you can see, the recognition by the Nobel Assembly is very recent and will hopefully highlight the impact of circadian rhythms in human performance that only now we are starting to understand. So the contributions of circadian physiology to human health, fitness and performance are vast, and more studies show evidence of this. Population analysis, such as the Nurses' Health Study, show that nurses subjected to shift work where their internal molecular clock is chronically misaligned with the external light-dark cycle is associated with greater incidence of breast cancer and obesity. As bad as shift work is the exposure to blue light emitting electronic devices like cell phones, tablets, computers and TV screens at night. Obesity, diabetes, and other metabolic diseases afflict 1 billion people worldwide. Studies have shown that the timing of food consumption independent of total caloric intake or macronutrient quality is a critical factor in maintaining metabolic health. So this means that more important than what you eat is when you eat it. Time-restricted feeding improves health by restoring the pattern of daily rhythms, reducing the risk of several diseases such as obesity, diabetes, myocardial infarction, stroke, chronic inflammation, cancer, and muscle fatigue, among others. Let me stress one more time that this improvement in health and fitness happen irrespectively of nutrient quality or quantity. The most important component is the timing of food consumption. To avoid the deleterious health consequences of circadian misalignment, restrict your meals to specific moments in the day, avoid exposure to blue light emitting electronic devices at night, and keep your bedtime constant.